Okay, good morning, guys. So this one is section 6.1, part 2. It's all about velocity. So there's certain formula that you need to recognize besides the arc length. So one of those is the linear velocity formula. So anytime that you want to find the linear velocity, it's v, which is the linear velocity. So that equals the arc length, s, divided by the time. Angular velocity, which is the W, so it's called W. So that equals theta divided by t. So theta, which is the angular displacement, we talked about that for the previous sections. So angular velocity, it's always the angular displacement, such as theta, divided by the time. And the linear and the angular velocity relationship, which is v equals r times w. And I can show the proof for this formula right here. So the reason why v equals r times w. So one thing that we have for the linear velocity and the angular velocity, so let's go to the top here. So let's say that we just solve for t in terms of v and s. So just cross multiply, we do have s equals v times t. So in order to isolate that t, so we do have t equals s over v. And then if you try to do the same thing here for the angular velocity, so we do have theta, so that equals w times t. And again, if you try to isolate that t by itself, so we do have t equals theta divided by w. Now, since we do know that's the same variable, the top and the bottom equation, so those are being isolated, the t. So basically, we can just set those two equations equal to each other. So v over s over v equals theta over w. And now from here, so we do know that s, which is considered r times theta, back to the formula we have from the previous sections, the previous part 1 of section 6.1. So that equals theta over w. So one thing that we can cancel both sides is that theta. So theta got canceled. And now what we can do here, we got r over v equals 1 over w. Well, because that theta got canceled already. And now from here, we can just cross multiply. So r times w. So that equals v. And this one is the exact same formula that we found. So what I just showed you here, this one is just the short proof about using all the formulas so we can prove that the relationship of the linear and the angular velocity. So now let's apply some formulas. So the one that we just went over. So find the linear velocity with the given arc length and the time. So we do have the arc length, 100 miles, and then the time, t equals 10 seconds. So in order to find out v, so basically this one is just divided. So s over t, so it's 100 miles over 10 seconds, reduce. So we do have 10 mile per second. So this one is pretty fast. Okay, and now the next one is quite similar. So v equals 200 feet divided by 5 minutes. So divide it, so we do have 4 feet per minute. Again, so it's pretty basic. And now the next one, so find the angular velocity. So the formula that we need to apply is the second one right here. So angular velocity, W equals theta over t. So W, so theta over t. So we do have 12 pi with the measure of the central angle, or the angular displacement, divided by the time, so it's 5 pi second. Okay, make sure that you put in the unit, so it's radian over the time, the unit second. So pi got canceled, so we left with 12 over 5. And the unit, which is radian, rad per second. Okay, so now we can try this one right here. So 24 radian. The time is 6 minutes. So 24 radian over 6 minutes. Divide it. It is divisible, so it's 4 radian per minute. Again, it's pretty basic so far. So now let's move on to the next slide and see what else that we have. So find the distance s traveled by the point in time t, given that w is 2 radian per second, and the radius is 4 inches, and the time is 5 seconds. So in order to find out that the arc length. So we can use either S equals V times T or S equals R times theta. Well, it depends on what kind of given information we have. So the one that's given here is W, and we do know the radius, and also we do know the time. So basically we can just find out V first. So using the relationship of the linear velocity and angular velocity. So R times W, the third formula, the one that we showed the proof for today. So radius, which is 4 inches, and then W is 2 radian per second. So multiply this together, so we got the linear velocity, which is 8. So that's 8 inches per second. So once we get the linear velocity, the time, and guess what we can find? We can find the distance, the total distance. So then that would be considered V times T. So V is 8 inches per second. And then the time, which is 5 seconds. So cross out the same unit. So we got 8 times 5, which is 40. So it's 40 inches. So this one is like a two-step problem. So you need to find out the missing element first. And then after that, you want to put into the one of those formula. And now let's try the next one. So we do have W, 15 radian per second. Radius is 5 feet. And then T, it's 1 minute. So this one, we need to find out the arc length, the total distance again. So one thing that you want to find out is that V once again. So 15 radian per second times 5 feet over 1 rad. So radian got canceled. So 15 times 5, which is 75. So 75 feet per second. But now this one is just the linear velocity. We need to find out the arc length, the total distance. So the time we have is 1 minute. So 75 feet per second. 1 minute equals 60 seconds. So we need to multiply the time. Make sure that you need to convert that to the same unit. So multiply this one by 60 seconds. Okay, so this one is for 1 minute. Okay, so cross cancel out the unit. So we do have 75 times 60. So 5 times 6, that's 30. 7 times 6, 42. Okay, so which is 4, 5. 4,500 feet per minute. Again, 5 times 6 is 30. And then 7 times 6, 42 plus 3. So 4,500. Okay, so now let's try the rest of this. So find the angular velocity in radian per minute. So got to be careful with the unit here. So it's going to be in radian per minute. So the way to rewrite it, it's like radian over a minute. So the one that's given here, it's a revolution per minute. So it's 10 revolution per minute. But now we need to convert that to radian per minute. Guess what we have to do? So since we do know that 1 revolution is considered 2 pi radian, so we multiply that 10 rev per minute by 2 pi radian per revolution. Okay, so the unit cancel out, and we left with 10 times 2 pi radians, so which is 20 pi radian over 1 minute. And also we do have 20 revolution per hour. So this time we need to convert the unit. So 20 rev over 1 hour. Now gotta be careful with the time unit here. We need to convert that hour to minute. So we do know that 1 hour equals 60 minutes. So that means 1 hour equals 60 minutes. And also we need to multiply that revolution by 2 pi. So 20 times 2 pi, which is 40 pi, divided by 60, reduce. So 0, 0 got canceled. 4 and 6 reduced by 2. So we got 2/3 pi, or 2 pi over 3, radian per minute. Okay? So now, what about for 5.8? Rotation per second. Okay, quite similar. So we need to do that conversion again. Okay, so I need more space. So let me just erase this part right here. So for the next one, it's 5.8. Okay, so 5.8 rod. Or we can use rev again. Doesn't matter. Well, let's use rod per second. So we do know that 1 second convert that to minutes. So we do know that 1 minute equals 60 seconds. Okay, so let's see this time. From a small unit to a big unit, so we need to multiply. So right up here, so now it's converting to a minute. So 1 minute equals 60 seconds. Okay, and now times 2 pi. Again, same unit, cross cancel. So 5.8 times 60. So 8 times 6, 48. 5 times 6, 30. Plus 4, 348. And then decimal point, the 0 got canceled, so 348 times 2 pi. And then 348 times 2 pi, so we do have 8 times 2, 16. 4 times 2, 8. Plus 1, 9. 3 times 2, 6. So 696 pi. Don't forget about the unit. Well, the rotation got canceled, so this one is radian. Again, rotation got canceled. So we got 696 pi radian per minute. Okay, so now let's see what else that we have for the rest of the slides right here. So for the next one, you want to find V and theta. If R, it's 8 inches. W is 4 radian per second. Well, certainly we can find V first. So V equals R times W. So we got 8 inches times 4 radian per second. And also you can convert that the radian, so 1 radian over 1 radian. So the unit just cross out, and then we got 8 times 4, which is 32 inches per second. And now the next thing that you want to find out is theta. So we do have V, we do have W, we do have, well, the thing is that we don't have the time. Okay, so in order to find theta, so theta can be found by using arc length, which is S over R, or theta can be found by using the angular velocity, W divided by the time. But here's the problem. It looks like arc length, it's not given. The time is not given, arc length, it's not given. So that means theta cannot be found. So theta cannot be found. So find v and theta if r equals 1 foot and the point of rotation is 20 rpm. So certainly this one we can find w first. So w, so it's 20 rotations per minute. So we need to convert that to angular velocity. So multiply this one by 2 pi over 1 rod. Cross out the same unit. So 20 times 2 pi, we do have 40 pi radian per minute. So this one is just an angular velocity. We need to find v. So v equals r times w. So radius, we do have one foot. So 1 foot times 40 pi radian per minute. So eventually this one is going to be 40 pi feet per minute. Now what about the theta? Displacement, angular displacement. Again, we don't know the time here. The time is not given. And also the thing is that we don't know about the arc length. So arc length, it's not given. So if you're missing two information there, so that means theta cannot be found. Okay, so now let's try the next one. So that means for theta, you can just say that no solution. This one too. Okay, so find W and theta if R equals 3 centimeters and V equals 8 centimeter per second. So again, one thing we notice, V equals R times W. So in other words, W equals V over R. So we do have 8 centimeter per second divided by the radius. So divided by the radius, that means you multiply by the reciprocal. So it's 1 over 3 centimeters. Okay? And then don't forget about the radian here on the top. So now this one, nothing can cross cancel, but it can cross cancel the unit. So 8 times 1, so it's 8. So it's A radian. Or A over 3 radian per second. So some of the problems, those are pretty basic, but got to be careful with the one that you have to find theta. So again, if the time is missing, and also the arc length, it's missing. So even that you're given with radius, W, theta cannot be found. Okay? So theta either can be found by using R over S over R, or theta can be found by W over T. If one of those information is missing, the time and the arc length, theta cannot be found. Okay, so now let's see what else that we have for the rest of this. So now it's getting a little bit more complicated. So the Earth rotates through one complete revolution every 24 hours. Okay, so let's just highlight the key phrase, the key word. This is one complete revolution for every 24 hours. So that means, excuse me, so this one that's showing, okay, let me just undo all this. Okay, so one complete revolution, so one rod. So the time it takes is 24 hours. Okay, so first thing that we can do, we can convert that to theta. So one rod, that means what? 2 pi radian. So the time it takes for one rod is 24 hours. So find the angular velocity of a person standing on the equator. So that means W equals theta divided by the time. So theta is 2 pi radian. Well, because that one complete rotation is 2 pi radian. Divided by the time, 24 hours. reduce. So 224, so it's pi over 12 radian per hour. Okay, so it looks kind of complicated, but the thing is that if you think about like finding W first, or finding theta first and then find W, is actually pretty straightforward. Okay, so for the next one, there's a little typo here, but let me just, okay. So a mixing blade on a food processor extend out 3 inches from its center. If the blade is turning at 600 revolution per minute, that's pretty fast. And what's the linear velocity of the tip of the blade? Okay, so here's another typo. In feet per minute. Okay, so one thing that we need to find out, so it's a word problem. A lot of people kind of confused with the word problem because that is kind of lengthy and there's so many information. So the best thing for you to find out is to divide the word problem into all the separated part. Okay, so now we do have 3 inches. So this one is just the radius of the blade. Okay, keep that in mind, it's inches. And we do know that the blade is turning at 600 revolution per minute. So that's pretty fast. So we do have 600 revolution per minute. And what's the linear velocity of the tip of the blade in feet per second? So we need to find out the linear velocity. So first thing that you want to do, you want to convert that 600 revolution per minute to angular velocity, or you want to convert that to theta first. So theta equals 600 revolution per minute times 2 pi over 1 rad. Well, basically this one will give you not just theta, but it's actually W, because that involved with the time. Okay, so revolution got canceled, so 600 times 2 pi, we do have 1,200 pi radian per minute. Again, this one just gives you that the angular velocity. And one thing that we notice, we do know that the radius is 3 inches. Now, in order to find out that the linear velocity, feet per minute, so we need to convert that inches to feet. So we do know that 1 foot is 12 inches. So that means we need to divide that radius by 12. Because we need to convert that to feet. So which is 1/4 feet. And we do know that V equals R times W. Back to the third formula, that the one we talk about today. So radius, 1/4. And the angular velocity, it's 1200 pi. Cross cancel. So 4 got canceled. So 1,200 divided by 4 is 300. So we do have 300 pi. And the unit, guess what? It's feet per minute. Okay. So this one is like a 3-step problem. So first thing that you want to do, you want to convert that rotations or the revolution per minute to the angular velocity. And then once you're done with that, you want to convert the radius, so inches to feet. So once you get those two information, we can apply the formula, the one we talked about today. So linear velocity equals radius times W. Okay, so now let's take a look at the other one here. Okay, so for the next one, the diameter of the Ferris wheel is 197 feet. And one complete revolution takes 15 minutes. Find the linear velocity of a person riding on the wheel in miles per hour and round to the nearest hundredth. That's a lot of information here. So one thing at a time. So diameter, it's 197. So that means the radius would be half of this. So 197 divided by 2. And we do know that one complete revolution, it takes 15 minutes. So one rev over 15 minutes. Okay, so find the linear velocity. Again, v once again. But we need to find v in terms of the unit of mile per hour. So that means it's going to be a lot of different unit involved. So first thing first, we need to convert that one revolution over 15 minutes to angular velocity. So the way to do that, so W equals 1 rev times 2 pi radian, and then divided by 15 minutes. So it's 2 pi over 15, and it's radian per minute. Now, but the thing is that this one is just radian per minute. So we need to convert that to radian per hour. Okay? And also, the radius, oh, here's step 1. So we just convert that revolution per minute to radian per minute. The next step, you want to convert the radius from feet to mile. So feet to mile. So we do have 197 over 2 feet. We do know that 1 mile equals 5,280 feet. So that means we need to divide it by 5,280 feet. 280. Again, so this one can say that feet. Mile, we can put it on the top. Okay, so this one, the unit got canceled, so it's 197 divided by 2 times 5,280. So 2 times 8, well, 0, bring it down. 2 times 8, 16. So 2 times 2, 4, plus 1, 5. 2 times 5, 10. So it's 10,560. And then this number, you can do it on the calculator, reduce it, you'll get mile. So it's going to be a small decimal. So now what we got here, so we just convert that radius from feet to mile. And now, finally, so step 3, let me just write it down here so I need more space. So we do know that V equals R times W. So radius, what we got here, it's 197 over 10,560. Again, let's put in the unit. So this one is mile times angular velocity. So we do have 2 pi over 15 radian per minute. 2 pi over 15. We do know that's radian per minute. So got to be careful with this. We need to convert this one to mile per hour. So that means we need to multiply this one by, okay, so we do know that 1 hour equals 16 minutes. So we need to multiply by 16 minutes on top. And also, this one's mile over, okay, let's put in that separated radian here. Because radian eventually is going to get canceled. So minute cancels out with the minute. So what's left here? See that? The unit, it's mile per hour. So whatever the number that you have left right here, so just multiply them straight across, or you can just reduce the number first. So 15 goes into 60 4 times. And obviously the 2 got canceled with this, so this one turns out back to be 5,280. So we got 197 times 4, and then divided by 5,280. So you guys can find out what this is on the calculator. Okay, so let me check that. So it's going to be a big number. Well, it's going to be a very small number, actually. So it's 197 times 4 divided by 5,280. So eventually the answer is going to be, well, this one is about. It's about 0.149 unit mile per hour. So that's how fast, the Ferris wheel, the car ride travels, from one position to another position. Okay, so now let's take a look at the last one. Okay, so let me just clear all this. Okay, so a woman rides a bicycle for 1 hour and travels 16 kilometers. So find the angular velocity of the wheel if the radius is 30 centimeters. So we do know that 1 hour it travels 16 kilometers. So basically this one you can say that V equals 16 kilometers per hour. So the one that's given for the first statement here, so that's just the linear velocity. And now we need to find the angular velocity of the wheel if the radius is 30 centimeters. Well, it depends on what you want. For the final unit, you can always convert that to centimeter, radian per hour. Okay, you can convert that to radian per hour, or you can convert that to radian per minute. But it doesn't specify any unit for the angular velocity, so let's just convert that to radian per hour. Okay, so one thing that you need to note, you need to be careful. We do have kilometer and centimeter. So let's just convert that kilometer to centimeter. So we do know that 1 kilometer equals 1,000 meters, and 1 meter equals 100 centimeters. Okay? So first thing that you want to do, you want to convert that angular, the linear velocity to centimeter per hour. So basically we need to multiply this one by 1,000 and then 100. So we do have 16,000,000. So basically this one is 1,600,000 centimeter per hour. So that's the unit we need to convert first. And now we do know the radius. So the radius is 30 centimeters. So one thing we notice, W, so that equals R times the other way around, actually. So V equals R times W. So that means W equals V over R. So for V, we do have 1,600,000. Okay, so this one, it's a centimeter per hour. Times, well, divided by R, that means you multiply by the reciprocals of R. So 1 over 30 centimeters. So the 1 right here, you can put that radian on top of it. And then centimeter got canceled. So 0 got canceled. So the rest of this, you can just divide it. But the thing is that it's not divisible. So eventually, it's going to be 1600. 1 0 got canceled out, so we do have 2 more zeros there. So it's 160,000 over 3. And it's radian per hour. Okay, so then that'll be the angular velocity. Okay, so that's it. So that's all the lecture today for 6.1. Again, this one is part 2 of 6.1. So make sure that you guys watch both videos. The one that I put out for 6.1 part 1 and this one right here. Okay, so I'll see you guys next time.